students. Let's continue the class. The next topic is Unit 5, Similarity Based in Reinforcement Learning. Similarity-based approaches limit the notion of liberty, similarity between states or state action paired to generalize the learning process. So similarity-based approaches means the states between state action pair. So these two are the generalized by the learning process. So next, the idea is used to similar states to inform the decision and value estimate from the current state. What are the states or implement to the state action pair to generalize the idea to similar state to inform the decision tree, the value function of q comma s comma t, q of s comma t, s comma a, that functions will called as the current state estimation. So comes under the kernel method, the two methods we have to following the function. Kernel method, matrix learning. So kernel method, I already told the k nearest neighborhood learning in that decision tree. K nearest learning, the clustering function I have to already told that, no. So that topic is continue this descriptions of that. So use kernel function to measure the similarity between states. Common kernel include Gaussian RBF kernel, polynomial kernel and Gaussian similarity. Algorithm like K nearest neighbor, KNN algorithm. This one part of algorithm to find the clustering data, multiple clustering and single clustering data. Okay. The similarity between states to make prediction. So in KNN can be used to estimate the function value by averaging the value of K nearest state. So the kernel method is nothing but common kernel is called as RBF. Okay. The RBF kernel, polynomial kernel is one core part of the cluster to find out the data of multiple data or single data to optimizing the clustering method. So that clustering method, how to find out the nearest part of the cluster to arranging the data in single and multiple clustering. So that algorithm is used in the KNN. Okay. So the KNN can be estimate the value function. Value function is state and action. Okay. So the value function V of S comma A, the value of K nearest state. So the kernel methods to implement the matrix learning. What are the matrix learning means? Learn the distance matrix, reflect the true similarity between states. The state action pair and state action current state. Okay, these two similarity reflected to the between states. So this can improve the performance of insta-based method and kernel-based methods. So next one, the graph-based in reinforcement learning. What does mean by graph-based reinforcement learning? Means the model environment graph node that represents states or edge represents transition between states. So state and action, what are the function to following the process of premises, the represent the nodes of state, edge and columns. Okay, this method will called as graph method, graph based method. So this method is exploit the graph structure to improve the learning decision making, DMP. So the two models, we have two algorithms we have implemented in this graph-based algorithm. What this means? Markov decision process. Already we saw that the unit 2 and 3, the Markov decision process. So that will directly represent the algorithm to transfer. We'll see the briefly in definition itself. MDP. MDP means represent the graph, states and nodes and actions and edge leads to other node. standard RL algorithm can be applied directly to the graph representation. So this algorithm will like the graph representation, that edges and tree structure graph representation. We have to implement the learning of decision making, so that we use the MDP method. Next one, GNN method. What is it? Graph neutral network. Graph neutral network to optimize the graph, to combine the neural networks to construct of the state space. GNN can be used to generalize the value functions of policies over the graph. So these are and all called as the graph base. So first one is the MTP and GNN. So the two methods to we have used in the graph representation for what purpose? Nodes and action. The edges of the standard algorithm to apply the direct to the graph representation. So the structure of the state space is called as a graph neural network. We have to find out the structure of the state space and to generalize the value function of V of S comma A, that to implement the policy over the graph to represent in the graph environment. Okay, so the unit 5 is over. Thank you, students. The session is over. We'll see the other premisor points and premisor function to the implement representations. Okay, thank you.